In this video, we'll be looking at a quick preview and overview of carbonyl chemistry. So we're going to talk a little bit about categories of carbonyl compounds, and we'll look at an overview of reactions of carbonyl compounds. Now, all of these are going to be discussed in the current chapter 19, also chapter 20, 21, 22, and 23. So we have a lot to talk about in terms of carbonyls and carbonyl chemistry. Now, in terms of carbonyl compounds, they all contain the acyl group. So the carbonyl connected to some R group, but it's what's over here that distinguishes the carbonyl-containing compounds into two broad categories. You also need to remember the names of these different functional groups. So this first example here is an aldehyde, followed by a ketone. Over here we have a carboxylic acid. This is an ester, an acid halide, or acyl halide. This is an anhydride. This is a thioester, and an amide. So a lot of different carbonyl-containing compounds. But what you'll notice is that we can split these up into two big categories. One category includes aldehydes and ketones, and what's connected to the acyl group is a bad leaving group. Right, so the hydrogen or an alkyl group, that is not a good leaving group. It can't stabilize a negative charge. So these compounds are going to undergo nucleophilic addition reactions. On the other hand, when we look at the column on the right, carboxylic acids, esters, all of these groups beyond the blue acyl group, all of these can act as leaving groups. They can stabilize a negative charge. And so this group of compounds will undergo nucleophilic acyl substitution. So the difference in leaving group ability translates into a difference in reactivity. Okay, these compounds will undergo nucleophilic addition. These compounds will undergo nucleophilic acyl substitution, which is also called nucleophilic addition elimination, because there's an addition followed by an elimination to give overall a substitution. So in the next several chapters, we're going to be looking at a few different reactions of carbonyl compounds. First of all, we're going to look at nucleophilic addition reactions, and this is what we're going to discuss in chapter 19. So if we have our carbonyl-containing compound and our nucleophile adds to the carbonyl, that's going to push these electrons up onto the oxygen. So that gives us this intermediate. When the Y group is a bad leaving group, then the next step is going to be protonation. So the oxygen is going to grab off a proton. It could be from the solvent. And what we end up with is an alcohol. So this is a nucleophilic addition reaction. Some types of nucleophilic addition reactions will undergo one more part, and they can lose water from, if there's a hydrogen here, as well as this OH, and then you will end up with something like this. So this is the first reaction that we're going to be looking at, but we're still going for our overview. So the next example is nucleophilic acyl substitution. This starts out the exact same. So the nucleophile shares its electrons with the carbonyl carbon, pushing these electrons up onto the oxygen, and that gives us this intermediate. like that. But in this case, if Y is a decent leaving group, then the next thing that happens is that these electrons will come back in to reform the double bond, pushing away the Y group as a leaving group. And so what that gives us is this. So we have a new carbonyl-containing compound where our nucleophile is now the group that is connected to the carbonyl. So one group has been substituted by another group. We're going to talk about nucleophilic acyl substitution reactions a lot more in chapter 21. As we continue our overview of reactions of carbonyl compounds, the next one I wanted to mention is alpha substitution. So in this case, we have a carbonyl-containing compound, and this is treated with a base. The base can grab off a proton from the carbon adjacent to the carbonyl, putting these electrons onto the carbon, and that gives us this enolate. So we can draw another resonance structure that looks like this. So this is why it's called an enolate. It's an alkene and an alcohol, but the alcohol is an anion. So this is an enolate. Now the enolate, the whole thing, can act as a nucleophile. And so this carbon can share electrons with an electrophile, and we end up with something that looks like this. So for this type of reaction, whether this is a leaving group or not, it actually doesn't matter. What we're doing is we're converting our carbonyl-containing compound into an enolate, which is a nucleophile, and then that nucleophile can react with some electrophile. So that is alpha substitution, and we're going to talk about that more in chapter 22. The last general reaction of carbonyl compounds is a carbonyl condensation. We have, these could be the same carbonyl-containing compounds, they could be different, but what we need is for one of them to act as the electrophile and for one of them to act as the nucleophile. So just like we had up above, if there's a base that grabs off a proton and puts those electrons onto the carbon, well, those electrons can then be used to do nucleophilic addition. So these electrons can push up the oxygen, and then depending on whether or not the Y group is a good leaving group, you will end up either with the electrons stay on the oxygen and then it gets protonated to give this type of compound, or if Y is a leaving group, then these electrons will come back down, reform the carbonyl, and kick out this Y as a leaving group, giving you this type of compound. So carbonyl condensations, these we are going to talk about in chapter 23. So carbonyls are very important because they undergo many different types of reactions. But by understanding their properties, by understanding the distinction between aldehydes and ketones compared to carboxylic acids and esters and amides, then we will be able to understand that chemistry.